So here's an example of solving systems of equations graphically. So I've got a couple equations, and I always label my equations, and I've color-coded them so it's a little bit easier to see. So this is equation number 1, x equals 2y, x plus 2y equals negative 6, pardon me, and then x minus 2y equals negative 2. So we want to graph these two equations and then see where they intersect, and that's going to be the solution graphically. So first of all, let's take equation number 1 over here, and we'll make a little t-chart here and check our zeros. So when x is 0, if we look over here, when x is 0, we have just 2y equals negative 6, so y equals, divide negative 6 by 2, you get negative 3. And then when y is 0, kind of just cover that up, and you have x equals negative 6, so there's your points. So we just graph those. Negative 6, 0, so that's going to be right at the edge of my graph over here, so that's going to be here. That's negative 6. And then the other one will be 0, x is 0, y is negative 3. So using the intercepts is a very easy way to graph these, so we just connect that with a straight line. And you might want to be really accurate when you're trying to solve systems of equations graphically, that you get the lines right through the points. All right? So there's equation number 1. Now let's take a look at equation number 2, and let's find some points for that. So again, we could just draw a mini t-chart here, x and y, and x is 0 and y is 0. And when x is 0, if we look at this, we have, well, I could just cover that up, and I see negative 2y equals negative 2, so y equals 1. Okay. And then when y is 0, I could just kind of cover that up there, and when y is 0, x equals negative 2. So now I just graph those 2 points. So I got 0, 1. So when x is 0, y is 1. You can see that. And then I've got when x is negative 2, y is 0, so negative 2, 0. And then I just connect those 2 points. And there we go, something like that. So be careful, like, yeah, I try to make sure I can touch both points. And this is actually equation number 2. You could label it with the Roman numeral, since I already know what it is, or you could actually just write the equation over there. And this is equation number 1. And then sometimes we actually just label them, so this would be x plus 2y, negative 6, and then x minus 2y equals negative 2. Kind of spruces it up, makes it look a little more professional. All right, and where do they intersect? That's going to be our solution, and they intersect at this point here. And looks like that's going to be x is negative 4, and y is negative 1. So there's your solution. So you found it graphically. And sometimes if we write a solution set, we'll have that 1 point, negative 4, negative 1. Okay? Now again, remember, when we have this relationship and we graph this line, these are all the points where if you take the x and you add 2 times the y, you'll get negative 6. So if you take any point on this line, and if you take the x value, they all have coordinate, or ordered pairs, like this point over here is negative 2, negative 2. If you put this in, if you take negative 2 plus 2 times negative 2, you get negative 6. Any point on this line, the x and the y coordinates satisfy this equation. And any point on this line, if you take the x coordinate and you subtract 2 times the y coordinate, you'll get negative 2 for any point on this line. So when we are looking for the solution, we're looking for the point that satisfies both conditions at the same time, and that's the solution right there. In other words, if you put negative 4 and negative 1 into this equation, the left side will equal the right side, and if you put negative 4 for x and y, negative 1 for y, in this equation, the left side will equal the right side. So they satisfy the equation. So that's what we're talking about. Okay? So I hope that'll help.